Hi everyone, I am Dr. Noraziah Adzhar. So let's continue the second subtopic of chapter 2, which is the quadratic equations and expression. A quadratic equation is a polynomial equation of the second degree. So that means your equation having the highest power of 2. A quadratic equation is in the form of ax squared plus bx plus c equal to 0. So this is the standard form of the quadratic equation, where a cannot be 0 because if a is 0, so you are not having the power 2 in your equation. Thus, you are not having a quadratic equation, but you are having a linear equation, where the value of a, b, c are constants. Finding root of an equation simply means we are finding the value that satisfy the whole equation equal to 0. So we equalize the whole equation equal to 0 and we are finding what are the value of x that satisfy the whole equation. A quadratic equation has at most two different roots. Let's see this table, type of roots. So the nature of the roots can be determined through this formula b squared minus 4ac, which we call it as discriminant. The nature of the root can be categorized as follows. So when you substitute the value of a, b, c from the equation into this formula, so you are getting a certain value. So if the value is a positive number, that means your equation having two distinct real roots. They are real and they are different. For example, x equal to 2, x equal to 3. If the number is less than 0, your equation is having two distinct complex roots. So they are non-real and different. If the value is 0, so that means you are having two equal real roots. So the two roots are equal and real. So that means you are just having one real root. For example, x equal to minus 1. Right, so these are the three cases illustrated by the following graph. If the b squared minus 4ac is a positive number, you are having two distinct real roots and the graph maybe look like this. If it is a small graph, so it's going to intersect x-axis at 2 points, two different points. If the value is 0, it's going to intersect the x-axis at only 1 point. If it is less than 0, the graph will not touch the x-axis, thus we are not having the intersection value on the x-axis. Alright, so next the example. Determine the nature of the following equations. Alright, so 3x squared plus 2x minus 1. So a is positive 3, the value coming from x squared. B is the value coming from x power 1, positive 2, and c equal to minus 1, the constant value. So substitute into b squared minus 4ac and we are having 16 as the answer. So 16 is a positive number, so we are having two real and different roots. For b, 5x squared plus 64. So 5 is the value for a. B is equal to 0 because we did not have x power 1 in the equation. So b is 0 and c is 64. So the answer is 1280 negative. So the discriminant is negative. So we are having no real roots. So how to find those roots of equation? So there are several methods. The first one, we can use the factorization method, or we can use the completing the square method, or the third method is by using quadratic formula, or the last one, we can use the graphical method to identify the root of the equation. Let's go to the first method, factorization. A quadratic equation in this form can always be expressed as a product of two linear equations. We can always factorize a quadratic equation into this form. So using factorization method, so how to do it? For example, we have x squared plus 3x minus 4 equal to 0. Right, so let's build up a table. So this table having two columns. So the first column is the column for x squared, the column for power 2. If you are having 2x squared, so write down here 2x squared. If you are having negative x squared, so write down negative x squared. And the last column is the constant value in the equation. For this case, it is minus 4. Okay, so we are taking the x squared and the constant value. All right, so the following elements in the column is the product or the factors of this value. For example, x squared, the factors of x squared is x times x, so we are getting x squared. But this case, it is minus 4, so we need to identify what are the factors of minus 4. We can have minus 2 times 2, minus 2 times 2. You can have 4 times minus 1, or you can have minus 1 times 4. So out of these three choices, we need to try and error which one is the most correct value to be put here. So how to know which one is the correct one? We need to perform the cross multiplication. So this is the first cross, and this is the second cross. So the first cross, x times with minus 1, giving you minus x. And we add up with the second cross, so it is plus x times with 4, so 4x equal to 4x minus x is 3x. So this value must be equal with the second term of the equation, the term for x power 1, together with the sign, positive 3x. So this is also positive 3x. So that means x plus 4 and x minus 1 are the two factors of this coefficient. Okay, so remember, for this case, we have three choices, whether it is 4 minus 1, minus 2, 2, or minus 1, 4. So you can try out these two. So you are going to get that you'll never get the 3x positive for these two. Okay, so in this case, we need to try an error. So the answer is x plus 4 equal to 0. So we are getting minus 4. X minus 1 equal to 0. X is equal to 1. So you can always check your bracket whether it is correct or not by expanding your bracket and show that you are getting the original equation. Alright, next example. Solve 6x squared plus x minus 12 equal to 0 using factorization method. So for example, we are finding the factors for 6x squared, the term of x squared, and the term for the constant minus 12. So in this case, 6x squared, we have several choice to get 6x squared. So we can have x times 6x as well. Okay, for the minus 12, you have minus 4, 3. We can have minus 3, 4. We can have 6, 2, 1, 12, and many more. Okay, so how to identify which value is the correct? So you need to play around with the numbers. So make sure that the first multiplication plus the second multiplication equal to 1 plus 2 must be equal to the second term of your equation. Okay, must be equal to the positive x. So in this case, 3x times 3 is 9x. So 9x plus minus 4 times 2x, so 9x minus 8x, so equal to x. So that means the table is correct, so we can take out the factors of the equation. So 3x minus 4 is the first factor, the first bracket, 2x plus 3 is the second bracket, the second factor, so equalize to 0, so you are getting x equal to 4 over 3 and x equal to minus 3 over 2 as the solution. So these values are the roots of this equation. Alright, the last example, by using factorization method, show that x equal to 3 over 2 and x equal to 1 over 6 are the solutions of the quadratic equation 12x squared minus 20x plus 3. So we repeat the same thing, repeat the same table, play around with the numbers so that the first multiplication plus the second multiplication you are getting minus 20x. So in this case, 2x minus 1 is minus 2x plus minus 16x, minus 18x. So you are getting minus 20x. Okay, so this bracket equal to 0, so 2x minus 3 equal to 0, so you're getting 3 over 2 and 1 over 6. So this is the example for the proving question. Alright, let's go to the next method, completing the square. So these are the procedure for completing the square. So first of all, we need to make sure that the coefficient of our square of the x square, a must be equal to 1. It must be positive 1. If it is not 1, you need to divide the whole equation with the number a. Okay, like this. Okay, so we need to divide everything with a. So we are getting b over ax plus c over a equal to 0. Second step, we are dividing the coefficient of b over a with 2. And then rewrite in this form. So in this case, if it is positive, so you write down positive in the bracket. And we have the power 2 outside. And then repeat the same term, b over 2a square, but this one must be negative. Okay, must be minus and then plus c over a. So this one have it doesn't change from the first one, equal to 0. Okay, let's see the example. For example, x squared plus 3x minus 4 equal to 0 now by using completing the square method. Okay, in this case, the coefficient of x squared is already 1, so we don't have to divide the whole equation with any number. So we just continue. So write down so first of all, 3 need to be divided by 2. So 3 over 2. So write down in this form. So x plus, since it is plus, so this one is plus. So write down 3 over 2. So 3 over 2 and then we put square outside. And then we need to minus. So this one, you need to add this. Minus 3 over 2 square. Minus 4 equal to 0. Okay, so this equation is equal to this equation. So you can check by expanding this equation. So if you expand, you are getting the original equation. Okay, so the coefficient of x we divide by 2 and then write down in this form. Second step is, so this one doesn't change, so x plus 3 over 2 square. Alright, for this one, we need to simplify this, solve this for a number. So when you're solving this, you are getting 25 over 4. Bring this to another side of the equation, 25 over 4. So solve for the power 2, bring to the other side of the equation. You have the plus minus square root 25 over 4. And then x plus 3 over 2 is equal to plus minus 5 over 2. And x1, the first x is, we take the positive 5 over 2 minus 3 over 2. So x is 1. Second value, we take the negative value. Negative 5 over 2 minus 3 over 2 equal to minus 4. So x equal to 1 and x equal to minus 4 are the roots for this equation. Okay. Alright, next example. So now our x squared is not 1. We have 6 as the coefficient. So we need to divide everything by 6. So x squared minus 1 over 6x minus 2. Okay, we divide everything by 6. So you have this. Alright, so repeat the same thing. So we need to divide 1 over 6 with 2. So we are getting 1 over 12. So write down negative inside the bracket. And then 1 over 12 here. Divide by 2. 1 over 12 and then we have square. Okay. And then repeat the term inside the bracket. But we minus the term. So we minus this term square. Minus 1 over 12 square, and then we have the minus 2. Don't forget the minus 2 at the back. Okay, so solve for the number. So we are getting 289 over 144 equal to x minus 1 over 12 to the power of 2. So power of 2 bring to the other side of the equation. So we are having this. So this one continue. So we have this plus minus 17 over 2, and then we solve for x. So x1 is 3 over 2, x2 is 4 over 3. So these are the roots of this equation. So how to know whether our answer is correct or wrong? It's very easy. We just substitute the numbers 3 over 2 and 4 minus 4 over 3 into the original equation. Okay, substitute into the original equation. So make sure that you are getting the value 0. If you are getting the value 0, so that means your value of x is correct. Alright, the third method is by using a quadratic formula. Alright, so the formula is given by this: x equal to minus b plus minus square root b squared minus 4ac over 2a. Okay, for example, x squared plus 3x minus 4 equal to 0. So we want to find the value of x in this equation that satisfies the whole equation equal to 0. So a is 1, b is positive 3, c is minus 4. So substitute into the formula and then we solve for the formula. So we get minus 3 plus minus 5 over 2. So we have 1 and minus 4 as the answers. So these answers are actually the roots of the equation. Alright, so you can try this example as well and try to show that you are getting minus 3 over 2 and positive 4 over 3 as the answers by using quadratic formula. Alright, the last method to identify the roots of a quadratic equation is by using graphical method. So the graph of a quadratic equation is either a concave up graph or a concave down graph, either a smile graph or a set graph. So how to identify the smile or the set graph? So if the coefficient of x squared is positive, so you are going to draw a smile graph. If the coefficient is negative, so the equation is having a set graph. For example, x squared plus 3x minus 4 equal to 0. So x squared over here having a positive 1 as the coefficient, so the graph will be a smile graph. So never draw a set graph for a positive x squared equation. Okay, so how to draw the graph? So your graph can be done by making a table of values. So you set a values of x and then find the values of y and then plot the points and join all the dots. Alright, or by using a graphical calculator that have been introduced in the first part of chapter 2. Alright, so in this case, let's say you have this. So you're going to have the intersection on x value. In this case, it is minus 4 and 1. So these intersections are the roots of the equation. Right, next example. So now we are having minus 6x squared plus x plus 12. So minus 6x squared indicates that the graph of this equation is a set graph. So when you draw the graph, You notice that you are having two intersections at x-axis, and these intersection values are minus 4 over 3 and 3 over 2. So these are the roots of the equation. Alright, so we have done all the four methods to find the roots of the equation. So let's try the last example. So this is the test questions from 2010-2011 semester 1. If the equation x squared plus p squared plus 12 equal to 4 plus 2p times x have equal roots, find the value of p. Alright, so what to do? The first thing is we group all the terms according to their characteristic of x squared, x, and constant. So a is 1, b is this term minus 4 plus 2p, and the last constant will be c. So substitute into the discriminant formula because you are given the nature of the root. So remember the discriminant b squared minus 4ac. So you are getting 16p minus 32. Having equal roots, so that means your discriminant is equal to 0. So this is the formula for equal roots. B squared minus 4ac equal to 0. So solve for this, you are getting p equal to 2. Alright, so that's all for chapter 2.2. Thank you.